All right, so these are the hard ones, right? So for this one, we're going to have to solve first a kinematics problem, right? And then I believe we solve F equals ma, right? Okay, so x vi vf a t. Okay, mass is moving upwards and stops. Okay, distance of 6.2. So it moves upward, I think, when it stops, right? 2.10 seconds. Oh, the final velocity is 0, right? The time is 2.10 seconds, right? And then we got to find A, and the problem is that there's no formula that they all have VI in it, right? So this one's actually kind of a pain in the butt, right? So what I'm going to do is I'm going to go X is 1/2 VI plus VF T, and I'm going to solve for VI, then solve for A. So 6.2 is 1/2 VI plus 0 times 2.10. Now, when you do the math on this, you type 6.2, you multiply by 2, divide by 2.10, and you'll have VI plus 0. So VI plus 0 is 5.9047. That's VI plus 0. So again, I type the 6.2 in, right? Multiplied by 2 to get rid of the 1/2, divided by 2.1 to get rid of the multiplication of it on this side, right? And I get what is equal to VI plus 0. Of course, that's just VI, right? So VI is 5.9047, and now I want to solve for A. I choose this guy, VF is VI plus AT. It's like, gosh, I'm not even done yet. Okay, so 0 equals 5.9047. That's a 0, not a 6, plus A times 2.1. All right, and then let's see, negative 5.9047 equals A times 2.1. Divide by both sides by 2.1. So I get negative 2.81179 meters per second. So it's like normally we'd be done with a problem. We've done all this work. Okay, but we haven't even started, actually. Okay, we have started. Okay, so here's a mass on a chord. Boop, 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 boop. And now we have to do F equals ma, right? Okay, so let's see. What is it? Okay, so they're asking us for the tension as it stops. So that's, I'm going to just put an F there. That's my variable, right? It's 4.3 kilograms, so we know how much it weighs. Or we can figure it out, right? So the force of gravity is 4.3 times 9.8, 42.14. So the downward force is 42.14. All right. So now we're all set. We're going to go boop, boop. Unknown force minus 42. It's equal to 4.3. And then I'm going to use this acceleration, right? There it is, baby. Times negative 2.81179. And the problem with these is if you mess this thing up, you won't know it till like 5 minutes later when you solve this. So let's see if I even get this right. Okay, so let's see. Okay, so what we do math-wise, we go 4.3 times that guy. And I've got negative 12.0907 on this side, right? All right, the next step is we add the 42.14 to both sides. And adding it to this side just makes that go away, right? So I'm going to go plus. And I get 30.04. So the force. Let me look at the answer here and then make sure I got the right answer for you guys. How sad would it be if I post something with the wrong answer? Number 5 should be 30.0. Yeah, okay. So I just added one more decimal to it. So 30.0 newtons. Notice that the force is less than the weight, right? Notice that it's accelerating down. So this is one of those counterintuitive ones, right? So if you stop moving upward, your acceleration is negative. When you do these problems, always decide before you do the problem whether it's accelerating up or accelerating down. This one clearly is down. So even if you mess up and you like miss this minus sign here, right, you know that it's going to be a negative acceleration, okay? Because it stops moving upward. Stopping up, going upward is accelerating downward, okay?